Hello and welcome back to another Physical Sciences 3 lecture. This time we're looking at energy transfer, and we're talking about work this time as a transfer of energy. So work is a transfer of energy. For example, if you are going to go and lift a bunch of weights, you need to have eaten some food which gives you some chemical energy, and then you can transfer that chemical energy into mechanical energy when you're lifting things. Okay, so when work is being done on an object, its energy level changes. So if you lift something up, it gets more potential energy, which we saw in the previous examples. Or if we move something faster, then we also have supplied that object with energy. So if we throw something across the room and we've given it some velocity, then that kinetic energy had to come from somewhere. So and we provide the work, so we did some work on that object if we threw something. And that work done is equal to the change in energy. Okay, so if an object starts going faster, it had to have had some work done to it, and some energy must have been transferred from the body doing work. So from the body doing work to the object having work done on it. So if we throw a ball, we have done work on the ball. Okay. For example. So let's have a look at this example now. So we have a 200 kilogram cart is moved from rest to be moving southwards at 5 meters per second. What was its final kinetic energy? Okay, what was its final kinetic energy? Well, EK is equal to half mass velocity squared, which is equal to half times by 200 kilograms, which would be cart 200 times by its velocity 5.0, and that is squared. So it's going to be equal to 0.5 times 200 times by 5.0. Oops, 5.0 squared. So 2,500. And that's joules. And just remember to write in joules when you're doing work, which I forgot to do in our last example. So make sure you're go back and put your units in. 2,500 joules. What is its change in kinetic energy? Okay, so change in EK would also be equal, since it's initial, so we can say EK, let's say F for final, final, minus EK, I'll put this in bracket, final and initial. So EK initial was 0 because it wasn't moving, it was at rest. So its initial velocity was equal to 0. So that means it had no kinetic energy. So it just means it's equal to 2,500 joules, because it started with nothing and then it got 2,500 joules. How much work was required to bring the car to that speed? Well, work is equal to change in energy. So that's also going to be equal to 2,500 joules. We had to provide the cart with 2,500 joules of energy to get it up to that speed of 5 meters per second. Okay, so the work done, or the work required, was that. If the accelerating force was 500 newtons south, how far did the cart move while the force was acting on it? Okay, so if the accelerating force was 500 newtons south, how far did the cart move? Well, work is also equal to force times displacement. Okay, so if we know that the amount of work was 2,500 joules, and this was 500 newtons south, times by S is equal to 2,500 divided by 500. Sorry if my S's and 5's look similar. So 2,500 divided by 500, you probably do that in your heads maybe, but 2,500 divided by 500 is equal to 5. Okay, so travel 5 meters, and that was south. So because S is displacement, we do need the direction in there, so 5 meters south. Okay, very good. Okie doke. Alright, so we'll do the next example in the next lecture.